Hello, calculus students. Welcome to another online lesson. Today we are going to continue our discussion on tree diagrams and specifically what to do when we have non-equally likely events. Again, using tree diagrams. And secondary, we are going to focus on Venn diagrams to represent categorical data for probability problems. Our goal being able to use both tree diagrams and Venn diagrams to solve IB level probability problems. To start with, I've got a list of terms and notation, some of which we've already seen, some of which you may have seen in other classes, and others maybe you haven't seen. And this is just going to help clarify our language moving forward throughout the rest of this unit. So we've definitely seen this before. P parentheses A, it's sort of like a function notation, but the capital P stands for probability. So if I see PA, that means the probability of event A occurring. Lowercase n, number of A, so it's the number of elements in set A, specifically sort of like the numerator of the probability, the frequency, if you will. When we see X, we're talking about our data. When we see this little symbol here, it kind of looks like a fancy E. It means element. So this means X is an element of set A, or it's part of set A. Here, again, we have the P, which means probability of, and then we have this symbol here, which sort of looks like an upside down capital U. It's the intersect symbol, intersect. Means and. Again, I often think of this as, if I can turn it into an A, it means and. So the probability of A and B. And then we have the, what looks like a regular capital U, but it's sort of different, sort of rounded. We've got the probability of A or B, and notice that one does not turn into a capital A, so that one means or. And that's technical name of that symbol is the union. So you've got intersect and you've got union. One means and, one means or. For this chapter, we'll be referring to or as inclusive, meaning it can be one, the other, or both, as opposed to just one or the other. A prime, prime means not or complement, so it's not part of A or not A. Disjoint means that they are not connected or overlapping, not connected, not overlapping. And then we've talked about this when we are listing elements of a set, we want to use set notation, specifically the braces. So you do your little gull-wing parentheses there on either end and then list all of the items within the set. All right, last class we started dealing with some tree diagrams for unequally likely events, meaning it's not like a coin flip and a die where everything has the same chance of happening. Here we have other information. So a bag contains 2 red sweets, 3 green sweets. Jacques takes 1 sweet from the bag, notes its color, and then eats it. Eats it means he's not putting it back. He then takes another sweet from the bag. Complete the tree diagram to show all probabilities. And finally, what is the probability of getting 2 different colors? Well, remember that all of our tree diagrams, they always have to add up to 1 every time we branch off. So if I've got 2/5 for red, I automatically know 3/5 would be the complement, and those would add up to 5/5 or 1/5. I can also look up here and see that there were 3 green sweets. There were 2 red. That gives me a total of 5, which I see down here in the denominator, and the numerator was just the green, which was the 3 green sweets. Moving on, after I eat a red sweet, that means one of these reds will be eaten, gone. So I'm down to 1 red sweet. But I've also eaten one of my total candies, happened to be a red one, so I only have 4 left, so 1 out of 4 is my probability of getting another red. And the complement of that would be my green, so 3 out of 4, because these have to add up to 1. And then last but not least, they sort of helped me out here. They already did the 2/4. The complement of that is also 2/4, meaning they add to 1. Or if you take 1 minus 2/4, you're left with 2/4. We can also see that if we follow the path down here from the seed, there were 3 green sweets out of 5. We ate a green sweet right here. So that means that from the 3, we subtract 1, and we now only have 2 green sweets, a total of 4 sweets. And we can just multiply to get our final answers. Now it says, what is the probability of getting 2 different colors? Well, there's a couple ways to do that. This first path would be red, red. I don't want that. But the second path would go from red to green. And that's 2 different colors. So I want this one. And then I have the green followed by red. And that is also a path I want, 2 different colors. And then at the very end, it would be green followed by green, which is not 2 different colors. So I don't want that. I want the 2 different colors. Now we just multiply down the tree to find the probability of red, green, and then of green, red. Red, green, I take 2/5 times 3/4, which is 6 over 20. And then I've got 3/5 times 2/4, which gives me, again, 6 out of 20. Add those together, and I am left with 12 out of 20. You're welcome to reduce that. You don't need a label. It's probability. So we are slightly more likely to get 2 different colors. All right, moving on to our Venn diagrams. Venn diagram shows different classifications or categories of things. It shows if there are shared members, meaning if the sets intersect and have overlapping parts. The way we start is we always draw a box that represents our universe. It's our whole world, but we call it a universe. We represent it with U. That's not to be confused with the union symbol from the previous slides. So U stands for universe. It's our whole set. As we look at this problem here, a sports club contains 75 members. So our universe is the whole club, and it is 75 people. Then it says 15 just play tennis. And then it says 26 just play hockey. So I'm going to make a red circle that represents tennis. I'm going to make a green circle that represents the hockey. It doesn't tell me how many are in the set, but it does say that we have 15 that just play tennis. You'll notice here, by writing those 2 sets or circles and seeing them overlap, they've basically made 3 different little subsets. You've got this first one, which I'll outline in black, which is sort of like a crescent shape, sort of like a moon, or missing a little part there. Then you've got the green part here, which is, again, another sort of crescent shape, but in the other direction. And then, last but not least, you have what I call the American football looking shape, which is this sort of center, sideways eye looking thing. And those are our 3 parts. The ones on the left in the red would be those who just play tennis. The ones in the right, crescent shape, in the green would be the ones who just play hockey. And then the intersecting part is the ones who do both. Anyone who's outside of those circles but still inside the blue universe, those would be people who are part of the club but do not play hockey or tennis. So it says 15 just play tennis. So they would be hanging out over here in the tennis group, but not in the overlapping part with the hockey. And then we have 26 that just play hockey. They would be hanging out over here. Again, not overlapping with the tennis. 27 play both. They would go right here in the center. They are in both groups. Now, I can add up everything that's inside the red circle. That would include the 15 who just play tennis, as well as the black 27 who plays both tennis and hockey. If I add them together, I end up with 42, I believe. So I have 42 total members who play tennis. Now I can do the same thing with the green. I take the 27 who's both, take the 26 who's just hockey, add those together, I get 53. And those would be all the students who play hockey. Now, it said the universe is 75 right here. I don't want to add together the 42 and the 53 because those have overlapping members. Some of them are in both. But if I add up the 15, the 27, and the 26, I should be able to see how many members are participating total in tennis or hockey. If I add up 15 plus 27 plus the 26, well, I already know that 15 plus 27 is 42. And then I add on the 26, I get 68. So there's 68 folks somewhere in the circles, somewhere in the tennis or hockey set, which means that if I have 75 total, 75 minus the 68 means there's 7 people hanging outside the groups who are not part of tennis or hockey, but are part of the overall universe or sports club. Now I've labeled everything that's possible to be labeled on this Venn diagram, and I can start answering the bullet points. The probability someone plays neither tennis nor hockey. We just figured that out. There's 7. Again, we always take our desired outcome, which is 7 out of the total, which was the universe of 75, and our probability would be 7 over 75. The probability someone plays hockey is our second bullet point. Well, there were 26 who just played hockey, but this doesn't say just hockey or only hockey. It says hockey. And we added up and saw that there were 53 members playing hockey out of the 75 members. Probability someone plays tennis. Again, we already figured that out. There are 42 members who play tennis in total. That includes the ones who just play tennis as well as the ones who play both tennis and hockey out of the 75. And finally, the probability someone plays both hockey and tennis was almost given to us. The number was the frequency of 27 out of 75. And that is a Venn diagram. Once it's set up and labeled, everything becomes nice and easy. Our last example, a little bit more challenging. This time we're looking at different classes. We have a class of 30 students, or different subjects anyway. 16 study physics, 20 study biology, and 3 study neither. Our universe is, again, 30 students. Create a Venn diagram with this information and then determine the probability that a randomly selected student from the class studies the following. So I'm going to start off with my universe. Now, it might seem like you don't need to draw this. You do, absolutely. You'll lose points on the IB test if you don't draw the universe. So universe, label it with a U outside the box. It doesn't have to be in the upper left corner, but anywhere outside the box. And we know that that's all 30 students. Now we've got 16 who study physics. I also have 20 who study biology. This time it didn't say only. So there are actually 20 that study biology. Now the common mistake that I see students do is they put the 20 here. But that would imply that there's also some students that go right here that would study both. But that's not what it says. It actually says there's 20 who study biology. So the trick is put the 20 outside of the group. I don't know how many of those 20 just study bio and how many of those 20 study bio and physics, but I know there's 20 total who study bio. Same thing with physics, 16 study physics. So don't put that in the crescent, label it outside. That's the whole circle. Everything in the crescent part on the left as well as the football looking part in the middle are all studying physics. It says 3 study neither, so I can add that information right away. But there's still 3 little subsets or little groups that I don't know. I'm going to use the red lettering here, and I can see that this lowercase a here, I don't know that crescent. The B, where they intersect, I don't know that part. And then the C, I also don't know that part. That's a lot of variables that we don't know, but I think that's everything that we've been given. I want to figure out those values before I go on and answer any other questions. So let's think about our universe. Our universe is 30 members. I know that if I add up lowercase a, plus B, plus C, plus the 3 who don't participate in anything, that should add up to 30. Again, this A, this B, and this C.
At this time, all seniors report to the auditorium. All seniors report directly to the auditorium as quickly as you can. Thank you.
And we can write another equation here that just relates the A and the B. If we just have A plus B, we know those are the students in physics. Well, how many students do we have in physics? Well, that said was 16. So A plus B has to add up to 16. Now look at these 2 equations. We've got the red equation, A plus B plus C plus 3 equals 30. That's the whole darn thing. Then you've got this other equation, which is just the physics students. A plus B equals 16. Do you see any similarities between those 2 equations? Ideally, this A plus B that we see here is also seen here in the first equation, A plus B. So if A plus B equals 16, we can rewrite that first equation as 16 plus C plus 3 equals 30. And I will write that now. 16 plus C plus 3 equals 30. Now this is like a freshman algebra problem. We add together the 16 and the 3, giving us 19 plus C equals 30. Subtract 19 from both sides. C is equal to 11. So we can go back to our Venn diagram, put the 11 right here, and those are students who only study bio. Well, we know the whole set of bio has to add up to 20, and we can see that here. We've got the B and we've got the C. You can write another equation if you'd like. B plus C has to add up to 20, and we already know that C is 11, so you can do that. B plus 11 equals 20. Subtract 11 from both sides, and we get B equals 9. So I know that here. But you probably don't really need to go through all that work. We know that these two sections of the blue, the B and the C, have to add up to 20. So if you start with the whole of 20, take away the 11 we already knew, and that leaves you with the 9 on the intersect. Now we can do the same thing here with the P. We know the whole physics is 16. We know the intersecting part is 9. 16 minus 9 gives us 7. If you want to lose your variables now, that's fine. I did a lot of circling, so mine looks probably more clouded than yours does. But you can leave those in as well. So I'll put them back, but without the circles. A, B, and C. And we just use those parts again to help find those numbers. If I add them all up now, 7 plus 9 I know is 16, plus this 11 here gets me up to 27, plus this 3 here adds up to my grand total of 30. So I know everything checks out. And now we can start answering our questions. I'm going to erase my work at this point, so we've got a little extra room here. So we first want to find the probability that a random student from the class studies both subjects. Well, that would be the intersection or the overlapping part, which we see there's 9 students there, 9 out of the universe, which is 30. Physics, but not bio. But not. When I see that word, I get out my hand and I cover up whatever is said to be not. So not bio. If you cover up the bio, that would be covering up the 9 and the 11. And then look at what numbers you still have left. You have the 7 and the 3. So how many students study physics of those non-covered up numbers? That would just be 7 out of the 30. 7 students study physics, but not bio. Bio, but not physics. This time cover up the physics and see how many students just study bio. And that would be 11 out of the 30. At least one of the subjects. So those would be the 7 people that just study physics. I'm sorry, the 7 that just study physics, the 11 that just study bio, and the 9 that study both. That would be at least one. One, the other, or both. And so I add all those up, and I get 27 out of 30. Exactly one of the subjects. Well, those would be the people who just take physics or just take bio, which is 18 out of 30. And then this last one goes a little bit more advanced than we need to be at the moment, but we will be working up towards this. Given. Given means that we know additional information. So bio, given that we already know the student takes physics. Well, how many students take physics? Well, we can see that that is 16. So that's, anytime you see the word given or some similar term, that's going to be your new universe. We're no longer looking at everything. We're given 16 students. Of those 16 physics students that were given, how many of those take bio? We'll just look at the 16 physics students, and there were 9 that took bio, so 9 out of 16. And that is a Venn diagram, ladies and gentlemen. In the book, I have 2 separate parts to our assignment. The first one is going to focus on tree diagrams. The second one focuses on Venn diagrams.